Okay guys, we're going to do a few electron configuration problems from our PowerPoint. We have hydrogen, helium, lithium, carbon, nitrogen, and oxygen. We're going to need a couple of things, one of which is a periodic table, which I have here. You have one in your book. And you'll notice here above the letter H for hydrogen, that symbol is 1, and that tells me how many protons as well as how many electrons in the neutral atom. We're assuming all these are neutral atoms because they did not say there was a charge. And so hydrogen would have 1, and helium would have 2, lithium 3, and the next one on our list is carbon, which is over here with 6. You'll note I skipped a couple. And then I went on to nitrogen and oxygen, which are sequential after carbon with 7 and 8. So I'm just going to write down how many electrons they have so I know how many I have to deal with. And then we go on from there. Now that I know how many electrons, I'm done with the periodic table and I can put that away. The other thing I'm going to need is our electron filling diagram. You can use the one from the book. I'm going to use the one that I prefer because I can't do all those diagonals. So I start down here towards the bottom of my page with 1s. I go up one block and over one block and write 2s, and on the second level there's also 2p, so I write that down. Then I go up from the 2s and over one block and write 3p, or not 3p, 3s. We always start with s. And then we go to 3p. And since we're on the third level, we should have 3 possible letters. So that means the third one is going to be D. We go back here to the beginning, go up one and over one. And now we're ready for 4s, 4p, 4d, just like the previous row, but now we have to add the final letter, which is 4f. There are additional letters. We don't need them for our periodic table, and so we're not going to go any past f. And so this will describe all of these elements we have here. I'm going to go ahead and put the rest in just to show you how it works. So then it would be 5s here, 5p, 5d, 5f, and in fact we no longer need f after this, and so I'm not going to put f on the next on 6. I'm just going to put s, p, and d, and so we would do 6s, 6p, 6d. Then we go up here for 7s and 7p, and we don't need anything past there. How do I know that? Well, let me show you on the periodic table. So this is row 1, 2, 3, 4, 5, 6, 7. I don't need anything past, and this block here is the S block, so I don't need anything past 7S. And this is where 7P would be. And these actually insert, and we'll talk about those later. But this is our F block, and we only need 2 rows for F, so this would be 4F and 5F. These are my D blocks, so this is 3D, 4D, 5D, and 6D, and so I don't need any 7D. So here we are. How do we fill? Again, we start at the very bottom here with 1, and we go up from 1s. We drop down to the previous row. We go up 2s, so we would have 1s, and then 2s, and we drop down, and we go up here, which would give us 2p, 3s. We drop down and we go up here from 3s to 3p, and then up to 4s, and then we drop down and we go up here to 3d, 4p, 5s. And you get the idea. This is more than enough for the problem that we have before us. But just a little practice never hurts. So let's go ahead and look at hydrogen. We have just 1 electron. We're going to use the lowest energy available, which would follow the off-ball principle. And so I have 1s, and I'm just going to put 1 electron in there. Helium, now I have 2 electrons, so I can put up to 2 electrons in an s orbital, so I'm going to have 1s and 2. Now that completely fills the 1s orbital, so now I would have to go on to the next one, which is going to be for a 3rd or 4th or 5th electron. I'm going to have to go into the second row of the periodic table, or the second principal quantum number, and so this would have 1s2 completely filled, and then in the 2s it would have 1 electron. And so if I add up these numbers up here, my superscripts, and this is not squared or to the 1 power, these are 1 and 2 and 3, then I would have 1s2, 2s1, and that gives me a total of 3 electrons. Carbon, I need 6. So again, I start with 1s2. I go to 2s, because that's next, put 2 into there. I've used 4, I still have some more electrons, I need to put 2 more in, so I'm going to go to the next one, which would be P, and 2p, and P's can hold up to 6 electrons, but I only need to put 2 in, so it won't be completely full, but I have used up all 6 electrons. So how many electrons can go in each orbital? Well, S can hold up to 2, P can hold up to 6, D can hold up to 10, and F can hold up to 14. So let's do nitrogen. Nitrogen has 7 electrons. We would start with 1s2, 2s2, I've done 4, 2p, and I need 3 more, so I'll just put 3 in this orbital. It's not completely full again. Let's look at oxygen with 8 electrons. 1s2, 2s2, 2p, and I've used 4. I have 4 more to fill in, so I just need 4 in this one. I'm all done. Let's try not even knowing what the element is, but let's just pick a random number of electrons. Let's say we had 27 electrons. Okay, I don't care what the element is. I just start with my 1s2, go on to 2s2, still following this ordering. Next is 2p, and I'll put 6 there, and then I go on to the 3rd energy level and start with S2, and so here I've used 10, that's 12, I got a good ways to go yet. So after S is 3p, 6, and then after 3p is 4s, and let's see how many we have now. This is still 10, and this is 10 more, so that's 20. I have 7 more to go, and I've gone from here to here. So in the D, I'm going to put 7 electrons. So that adds up to 2, 4, 10, 12, 18, 27. So let's see if we can identify what element this is on our periodic table. We're going to go and find 27 electrons, which would be right here, and this would be cobalt. So, as you'll notice, the D is 1 letter lower than the S, but that's fine. We'll explain that in class and talk about it. It's also explained in your book. And I hope this was helpful. We'll do some more later. Thank you.